Hello, everyone. Thank you so much for connecting with us. Welcome to the Azure Sydney User Group March edition. And today we are going to talk about a lot of new stuff, um, starting up with the upcoming events. So I'll be sharing a couple of news and updates. And then we have a guest, Microsoft MVP Will Velida, who will be discussing about building globally distributed applications with Azure Cosmos DB. So let's get started. We have got some upcoming events coming up. So this is Microsoft Cloud Skills Hub. You can go over there, take participation, participate in the training, or attend any of the trainings, take challenges, complete them, win a swag, and of course you can enhance your learning as well. So it's cool stuff. Starting up with the public preview services. So we have got the managed certificate support now for the Apex or naked domains in Azure around app services. So the domains which do not have www, you can have the managed certificates for that as well. PowerFX, which is the low code language based upon the Excel, Microsoft Excel, is now an official language of the Power Platform and everything around Power Platform. So if you want to learn about that, you can go and write on Google or Bing PowerFX, and you can get the fantastic tutorials. It is also open source, so you can go and get and see how it is evolving. AZ copy is you can now copy your stuff from Google Cloud Platform storage to Azure Blob storage. The tags and everything will remain over there. So this is also one of the cool features. Then using app containerization tool in Azure Migration, you can also containerize the Java and .NET apps and move them to Azure Cognitive Services. Network routing is also network routing has got an update around service tags, which is service tags are actually used for to make them into what they do is they are group of IP addresses. So you can also use them for the better management, better setup of your networking. Moving on for the virtual machines around like Azure Virtual Machines, trusted launch. So you can use those trusted launch for better security purposes and compliance. Same goes for the automated guest patching for Linux. So the guest patching is you can get the updates automatically on your Linux VMs as well. Then we have got Azure Managed Instance for Apache Cassandra. This is the brand new service. It is used to deploy or manage your Apache stuff on Apache Cassandra, which is an open source system. So then we have got SQL management instance, so service broker message exchange between instances. We have got a support for service broker. If you are a developer, if you want to distribute the data workloads to different instances, you can do that now. Then we have got Cosmos DB support, Cosmos DB improvements around continuous backup. So you can restore the backup as well, and at any time it has got the role-based access control services now with Azure AD. So you can restrict who do you want to give to access or not. Then we have got the Kubernetes support around Windows in Saliso. It means that it was there already in Linux. Now we have got the Windows support. You can also plan your maintenance, so you don't have to worry about your hours, working hours or important hours. You can always plan around that. Azure. So Australian Central Region has got the logs, analytics, and application insights available, so you can easily go provision these resources and start using them. Fantastic stuff for your monitoring, for your application monitoring, for your service monitoring, or for your bots monitoring. Functions have got the durable function support. Python have got the support for durable. Not sorry, durable functions have got a Python support. Uh, it as .NET 5 has just been released as GA, or and now it has the support for functions as well. So you can create the functions in .NET 5 or Node.js 14. Communication services, which have just gone GA, one of my favorite services, although it does lack the support on the Australian region, which we are hoping that we get very soon. But yes, communication services, they allow you to send SMSs, make phone calls, and all of those communications you can embed in your applications, bots, or any other services. So they have gone GA. Application insights, so this is the no code integration which was already available for Windows. Now it is available on Linux app services as well. We have got media standby mode in the live for the live events, and bring your own key encryption in media services, so you can reduce your cost of managing your live events if you utilize this standby mode. Then we have got around cost management. We have got forecasted cost alerts as well that will also help you manage your billing. Around API management, we have got request and response, validation policies, and the other stuff as around along with the Visual Studio Code extension. It does not come with the basic Azure Tools extension, so you may want to install this separately as it is brand new. Cosmos DB has got the API for MongoDB 4.0 now. So as this is all about Cosmos DB, so if you have got any questions around that, please feel free to ask. Then we have got a bunch of stuff for Kubernetes service, as you can see on the screen. So I don't want to go into the detail each of them, but if you have got any questions around it, or after the session, please let me know, or during the session, just write it in the comments. If you have got any questions, feel free. We will be more than happy to answer these. Then there are a couple of announcements. So there is a new show. I think 5 or 6 episodes have been done already by Simon Wade and his team in Microsoft Australia. It is focused mainly on the developer side, and they are also heavily supporting the community around it. So what is going on in the community, Azure community, specifically within ANZ or Australian region as well. So it is broadcasted live on Thursdays, 11 a.m. or Sydney time. So if you are interested, you should watch it. I love this show. The best point of this show is the time duration. So it is short, and it is very, very, very good. If you want to join the newsletter of the Microsoft Source newsletter, you can go to this link and join it. It covers up the community content and the content which are provided or which are written by Microsoft Cloud Advocates and Microsoft Learning portals as well. So it has got a bunch of resources from the pro, like from beginners to pro. All kind of people can get benefit from this newsletter. If you are going to hang around till the end, we have a surprise for you, and that surprise is right there. So you will get the Azure Pass, which you don't have to use with credit card at all. So just hang around with us, and you can be one of the lucky ones. Now, I think we will take 2 minutes of break, and after break we will be joined by Will, where he is going to discuss about building globally distributed apps with Azure Cosmos DB.
Hey, Arafat, I'm just going to jump in here quickly so you don't feel lonely. Just make sure if you do have questions, folks, that you put them in the chat. Awesome opportunity for you to get questions answered this evening from Azure experts. Will does a lot of work in this space as well, particularly around the Cosmos DB stuff. So make sure you take the opportunity to ask the real questions. Will doesn't work for Microsoft, so he's going to be open and honest with his experiences. So make sure that you make the most of that opportunity. So let's get Will onto the feed right now. Hey, Will, I'm going to remove myself. All right, over to you two, folks.
Cool. Should I just kick off, Arafat?
Yeah. Kick off.
Fantastic.
Yeah.
Can you see my screen before I start rambling?
I can.
Yep, we can see your screen. Yep.
Awesome. Fantastic. All right. Good evening, everyone. Welcome to this session, Building Globally Distributed Apps with Azure Cosmos DB. My name is Will Velida. I'm a software engineer and Microsoft Data Platform MVP based in Auckland, New Zealand. And like Simon said, I'm primarily focused on Azure Cosmos DB. And part of my work, we work with it quite extensively. We also work a lot with Azure Functions, primarily built on .NET. We also have, well, in our stack, we use event hubs, blob storage, a little bit of service bus. I'm trying to think what else we use. I also work with Databricks outside of work as well. Try to understand Kubernetes where I can. But yeah, essentially, I like to spend my time hacking on various different projects using various different Azure technologies. Yeah. So what we'll be talking about today, I'm going to try and keep these slides very brief, but essentially I'll start off by talking about what Azure Cosmos DB is and what we can use it for. And then in terms of theory, I'll talk about partitioning in Cosmos DB and actually understanding throughput, understanding how those two concepts work together. And then we'll kick off into some demos. So I'll show you how you can create an account through the portal. I'll show you some infrastructure as code tools if you want a cooler way of actually provisioning Cosmos DB accounts, show you how to do that. And then I'll take you through some basic operations that we can perform on our Cosmos DB account using .NET. And then I'll also show you another demo using the Azure Cosmos DB change feed. And I'll explain a little bit more about that when we get into it. If you do have any questions, please put them in the chat wherever you're watching from, and I will answer them either towards the end or just before we kick off into the demos. Cool. So what is Azure Cosmos DB? So for those of you who don't know, Cosmos DB is Microsoft's globally distributed multi-model database service. So using Cosmos DB, we can build a variety of different databases using a variety of different data models. So we can build applications that use document models either using the SQL or MongoDB API. We can build applications that use columnar data using the Cassandra API. If you're working with key value data, a bit of experience using Azure Table Storage, there's a Table API, which is essentially Azure Table Storage on steroids, where you can actually build a globally distributed version of table storage using the Table API, and it's super quick and super simple to use, which is a fantastic service. Or perhaps you're working with graph data within your applications, and for that you could use the Gremlin API. In the comments, it'd be really great to just kind of gauge what kind of experience people have had with different types of document models. So if you've worked with MongoDB, if you've worked with Cassandra, or perhaps you've worked with graph data, it doesn't necessarily have to be using Gremlin. It could be anything else like Neo4j, sorry, or any other graph offerings. Or perhaps you're using Azure Table Storage. I'd be really interested to see what kind of distribution of different types of databases you're all using. That'd be really good to get that insight. So I could just pop that in the comment. Unfortunately, I don't have anything to offer for you to incentivize that. I'm just hoping you can do that for good free will. Anyway, Cosmos DB provides us with the ability, no matter what kind of a data format that we're using, to build highly responsive and available applications worldwide ensuring that the data that we need in our applications are as close to our users wherever they are in the world. And this is done through turnkey global distribution. So Cosmos DB is essentially a foundational service in Azure. So no matter where you're deploying your applications to, no matter where you want to deploy your Azure workloads in the world or any region, you can deploy a Cosmos DB account to it. And Cosmos DB will replicate the data to wherever your users are. So essentially, you can add and remove regions to your Cosmos DB account at any time. Cosmos DB will replicate your data to all the regions associated with your account while continuing to enable your applications to be highly available. It's elastically scalable in terms of both throughput and storage worldwide. It offers elastic scalability for your reads and writes around the globe. So you can scale up to thousands of requests per second, right up to millions and millions of requests per second. And you only pay for the throughput that you need to help deal with any spikes in workload that your application goes under. There's guaranteed low latency at the 99th percentile worldwide. This enables us to build highly responsive planet scale applications. And Cosmos DB guarantees less than 10 millisecond latencies for both read and index reads and writes at the 99th percentile, which provides us with rapid queries and responsive applications. There are also precisely defined multiple consistency choices. So with Azure Cosmos DB, we're no longer forced to choose between two consistency extremes. Cosmos DB provides us with 5 well-defined levels of consistency for us to choose from, depending on the requirements of our applications. And then with some caveats, there's no schema or index management required. So out of the box, Cosmos DB will automatically index all data and is schema agnostic, meaning that we don't have to worry about application downtime or managing schemas associated with managing schemas or indexes. And we can use Cosmos DB for a variety of different use cases. So I'm part of a team that are building event-driven microservices for banking applications. Other examples include that we might have IoT applications that require us to read telemetry recordings from devices all across the globe. We may have a mobile game that's used by gamers all across the world, and we need to bring their data as close to them as possible to enable some rapid performance. We might have web or retail applications with customers all across the globe or in different parts of the world. We need to be able to replicate their data as close to them as possible to provide some ultra-fast retail shopping experiences. Essentially, if you need a NoSQL database service that's ultra-fast and requires minimal management, then Cosmos DB is just a first-class choice for those requirements. So now we're just going to kick off into how partitioning works in Azure Cosmos DB. So Cosmos DB uses partitioning to scale containers to meet the performance needs for the applications. Every time we persist an item into a container, they're divided into something called a logical partition. And these are based on the value of a partition key that is associated with an item that we store in our containers. So we have a document and we have several properties within that document. We can specify which one of those properties is going to be our partition key. And that's essentially what we call our logical partition. Now, items within a logical partition will all have the same partition key value. So this is a property within our documents. For example, let's say if I have a container that was storing items related to hotels, and we store them in a container, and we give that container a partition key of city name. That's the name of our property. And if we have 20 different city name values for our container, essentially we'll have 20 different logical partitions created for that container. So keep that concept, logical partitions, in your mind. These logical partitions are then mapped to something called physical partitions. Now, physical partitions are essentially the internal implementation of the partitioning system, and they are managed by the Cosmos DB team. They're essentially just a fixed amount of reserved solid-state drive-back storage and compute. And it's probably best to illustrate this with an example. So, taking our container with hotels that's partitioned by city name. So every time we add a document to our hotel container that has a city name value of Auckland, that would be placed inside a logical partition. And say we add a bunch of documents, and each time they have different city name values, new logical partitions are created. They're mapped to physical partitions. Now, as you can see here in this example, one or more logical partitions can be mapped to a single physical partition. So in this example, we have logical partitions for Auckland, London, Redmond, and Paris, and they're all placed inside this physical partition. Now, depending on the size of these logical partitions, we may only ever require one single physical partition. We don't manage these physical partitions. The Azure Cosmos DB team does that for us. But we do need to consider a couple of things that physical partitions really depend on. The amount of throughput that we provision on our containers. Each physical partition can provide a maximum of 10,000 request units. And don't worry, I will explain very shortly what request units are, but just keep that in your mind for now. So I've been in I've been in situations, where essentially we've treated it kind of like a SQL Server box, where we've just provisioned 1 million request units, thinking that the more request units that we provision in this container, the more performant it's going to be because it's going to handle a bigger load. And it doesn't work like that. It doesn't vertically scale. What you'll see here is that Cosmos DB actually horizontally scales. And so instead of having just this one big physical partition that has 1 million request units on it, we have so many physical partitions that have been created that can only handle 10,000 request units, can handle the maximum of 10,000 request units for each physical partition. So that doesn't work. So yeah, just keep that in mind. And there's also the amount of storage as well. So each physical partition can store up to, I think the time of writing is 50 gigabytes of data. That may have increased or decreased. Probably hasn't decreased, but just keep in mind that there is a limitation on storage as well. Now, in terms of limitations, there's no limit to the amount of physical partitions that our containers can have. As our data grows and the amount of throughput that we provision grows, Cosmos DB will automatically create new physical partitions by splitting existing ones without affecting your application's availability. So when these physical partitions split, the data in a logical partition will still remain within the same physical partition. All that happens with the split in physical partitions is essentially just new mappings of logical partitions to new physical ones. Now, throughput that's provisioned on a container will be divided evenly amongst our physical partitions. In terms of partition design, it's important that we get this right to prevent something called hot partitioning. And here's just more examples of as more logical partitions are created, they can be mapped to new physical ones. So hot partitions occur within our Cosmos DB containers when our partition key doesn't distribute the amount of throughput or storage efficiently. And this results in rate limiting and an efficient use of throughput, which in turn can lead to higher costs. So let's use our hotel container as an example again. Say if we have a bunch of documents that belong to different cities and they look fairly distributed, that this partitioning by city name looks like a very good choice for our partitioning strategy. But then all of a sudden we persist lots of documents that have a city name partition value of Paris, and it kind of skews that distribution. It looks like there's a lot of them, and it's almost exceeding the threshold in terms of both storage and throughput. This logical partition for Paris is something that we would call a hot partition. If this was our application, we would need to reconsider using city name as our partition key, as it's important that our partition key evenly distributes throughput consumption and storage. So what makes a good partition key? How can we design this this better? So just to kind of recap, a partition key has two components, essentially the path and the value. Using our hotel example from before, we know that we can see that the partition key path is city name. Partition key paths in Cosmos DBs accept alphanumeric and underscore characters, and you can even set partition key paths on nested objects using path notation. The partition key value is essentially the value of our property. So in this example, Auckland would be the value of the partition key, and this value can be string or numeric types. Now, selecting a partition key is not rocket science. It's fairly straightforward, but it's critical to get this choice right. Because once in Cosmos DB, once you've created a container and you've selected your partition key, you can't change it. If you do want to change your partition key and your partition strategy, essentially what you have to do is you have to create a new container with the new partition key set on it. And then if you want to migrate your data, you have to migrate the data from your old container to the new one. And there are various ways you can do this. You can use Data Factory, you can use the change feed, but it's a heck of a process. It takes time. So my recommendation is do this ahead of time. Like, think about your partition key strategy. Think about how you're going to actually partition your data before having to go through that pain. I've been in situations where I've been watching Data Factory for an hour trying to migrate millions and millions of documents from one container to another, just because I didn't take the time to really think about my partitioning strategy. So good partition key strategies will have values that do not change. So essentially, when you commit your item with a partition value, you can't then go and update this value. So say if I add a document about a hotel in London, I can't go, oh, sorry, this hotel should actually, it's actually in New York. I need to go and update that. That can't happen. That will fail. That operation will fail. Partition keys should also have a wide range of values to ensure even distribution across logical partitions in terms of both throughput and storage. And then this in turn will ensure even throughput and storage distribution across your physical partitions as well. Now, your choice of partition key will actually really depend on what kind of workload that you're going to be performing on your container. So for read-heavy containers, you may want to choose a partition key property that appears frequently in your queries as a filter in the queries that you perform. If you find that you're developing a bunch of services and you're querying a certain property frequently, that could be a really good choice for your partition key, or that property could be a really good choice for your partition key. Now, for write-heavy containers, what we may want to do is use the ID of the document as our partition key value. And this is because the ID is guaranteed to exist. The ID property is guaranteed to exist in every item in our Cosmos DB containers. This item ID also has to be unique. So this can help achieve even distribution in terms of throughput and storage. So just to give an example for that, we have a couple of containers in my day job. We have a couple of containers that we use purely for write-only stores. So once we persist that document, we don't query that document ever again. Essentially, we just take the payload, put that into an event which sends an event via Event Hub. So if we don't need to query that data and we just need really super fast writes, essentially we can turn indexing off for that container and just partition it by ID, and just that gives us some real good performance benefits. If you do have to query the item and you know the item's ID when you're querying it, you can also do this because it's really good for performing efficient point reads. So we can actually help Cosmos DB optimize our queries by specifying our partition key as a filter. So taking our example of hotel container, we perform this query selecting all the hotels where the city name is equal to Auckland. And what happens underneath the hood is essentially Cosmos DB will route this query to the physical partition that this partition key value is mapped to. And what's great about this is that if we add additional filters to this query will still be filtered to that single partition. So we can add as many additional filters as we like. We're still efficiently routing our query to that physical partition where our hotels from Auckland sits on. However, say if we partitioned our hotel container by, say, a star rating property, and we wanted to query our container to return all the hotels with a star rating greater than 4, assuming a five-star rating system, then essentially what happens is this query is not scoped to a single physical partition. What will happen is this will cause our queries to be executed across partitions, or what is otherwise referred to as a cross-partition query. So cross-partition queries are queries that don't filter on partition keys. Essentially what happens is the query will fan out to all physical partitions and it'll be run against each partition's index. So each physical partition will have its own index. So when we run a cross-partition query on a container, we're essentially running one query per physical partition. And what Cosmos DB does is essentially aggregates the results across different petitions, and it can cause a bit of a bottleneck, since what we have to do is we have to wait for all of the physical petitions to return the results of the query before the query is finished. So to really visualize this, here we are performing our query to retrieve all the hotels in a container with a star rating less than 4. Our container in this example is still petitioned by city name, so we're performing our cross-petition query. We execute this query and we're not routing it to a specific petition. So essentially what we're going to have to do here is going to have to wait for the query to be finished on all physical petitions before the result gets returned to us. So you might be thinking, well, in terms of performance and throughput cost, this is something that we should avoid at all costs and not even indulge. And that's not entirely true. In fact, from time to time, it's highly likely that you're going to have to perform cross-petition queries. And there are a couple of options to actually make this more efficient, thanks to, there's some ways that we can set up our SDKs, or initiate our clients to actually handle cross-petition queries more efficiently. The thing to really keep in mind here is you should really look to avoid performing cross-petition queries with large containers, because every time we check a physical petitions index, we're charged more request units, and we're almost at the point where we're going to talk about request units. But essentially, queries are more expensive, and we're charged for this even if there's no items in the physical petition that fulfill our query criteria. So if we're performing our queries, say if there's no data on one physical petition that has any hotels with a star rating less than 4, we're still charged for performing that query because a query is still being performed against that physical petition, despite the fact that there are no results being returned back to us. So that's kind of a quick fire explanation about how petitioning works in Cosmos DB. Now we're going to move on to throughput. And essentially in Azure Cosmos DB, you pay for the throughput you provision and the storage you consume on an hourly basis. And your priority as a developer is to ensure that you have enough resources provisioned on your Cosmos DB account to handle all operations at all times. When we perform operations on our Cosmos DB data, we use something called a request units. And if you go through the documentation, this is referred to R user short. But essentially, request units are currency for throughput. And all this is just really an abstract of system resources such as memory, CPU, IOPS per second required to perform operations against our Cosmos DB accounts. Now, when we provision throughput, we provision it in increments of 100 request units per second, and we can increase or decrease the provision throughput at any time. So it's not like you provision, say, 400 request units and you're stuck with that for the lifetime of the container. You can actually scale this up and down depending on your workload requirements. When we perform different types of operations, the amount of request units that we consume can vary depending on a variety of different factors. And these include the size of our items. So the bigger the item that you need to persist into your account or need to operate on within your Cosmos DB account, the more request units you need to consume in order to perform those read and write operations for that particular item. I said at the start that by default, Cosmos DB indexes all of our items. But by fine-tuning our indexing strategy, we can actually consume fewer request units by choosing not to index some of the properties within our document and only electing to index a few select properties depending on our workload requirements. The amount of properties in your items also has an effect. So the more properties in your items, the cost of performing operations increase. The level of consistency that you configure on your Cosmos DB account. So just to talk about consistency a little bit, there are 5 defined levels of consistency that you can set in Cosmos DB. So you've got strong consistency, something called bounded staleness consistency, where you can fine tune how stale you want your data to be in your Cosmos DB account. There's session consistency, consistent prefix, and also eventual consistency as well. And I'll show you how that all works in the portal when we kick it off into our demo. But essentially, if you're working with the stronger levels of consistency, both strong and bounded staleness consistency, you can expect to consume twice as many request units when performing reads compared to the other relaxed consistency levels. Also, the complexity of your queries will have an effect on how many request units you're going to consume per query. And also, if you're working with server scripts, so you can write server-side scripts using JavaScript, you can write stored procedures, post triggers, pre-triggers, user-defined functions for your Cosmos DB account or container, sorry. And essentially, that also has an effect on how request units are consumed and how complex they are. Because if you think about your traditional kind of like main worker node situation, where you perform a query, you send that to a main node and it gets delegated out to worker nodes, essentially stored procedures will always execute on that main node because it needs to be acidic. So that will have an impact on how many request units you consume when you execute those scripts. Now, in Cosmos DB, we can provision our throughput in a couple of ways. We can either provision it at the database level or the container level. Think of a container. Containers kind of like a word for everything now in the cloud. It's not a container like a Docker container or anything like that. It's think of it as a table, but just another word as a table within a database. But it's just called a container. They used to call them collections as well. So you can think of it as that as well. So if we do provision it at the container or the collection level, essentially we provision throughput and it's guaranteed for that container. So it receives that provision throughput all the time. And this is great because they're financially backed by service level agreements. And provided that we've petitioned our data effectively, then the throughput that we provision for a container will be distributed evenly amongst all its physical partitions. And those physical partitions belong exclusively to that container. So my general advice is that if you want guaranteed performance for a particular container or a collection, then you should really provision throughput at the container level. However, you can also provision it at the database level. Now, when we provision throughput at this level, we essentially say, okay, so the throughput that we provision will be shared amongst all the containers within that database. So say, for example, I've got 5 containers within a database and I provision 10,000 request units at the database level. I can't say that container A is going to receive 6,000 request units per second and the rest are just going to have to fight it out for the remaining. Essentially, depending on your workload demands and what's happening within your containers, that throughput will be shared amongst all of them. And this is similar to hosting a database amongst a cluster of machines. Yeah. Okay. So there's no guaranteed performance at the container level, like I said, but it works out slightly cheaper. So thinking about an example from work, we primarily opt for provisioning throughput at the container level, but there are some databases that we used to have a very, very slow, low traffic. So we just had a couple of containers that would share a minimal amount of throughput because we didn't need that performance at the container level. Now, back when we first were starting with Azure Cosmos DB, there are a couple of ways of provisioning throughput, but at the time of when we were first starting to develop applications using Cosmos DB, we could only provision throughput manually. And essentially what this is we set a hard upper limit of throughput for a particular container or a database, and then we will pay for that upper limit at an hourly rate. Now, in order to provision throughput correctly to ensure that our application can satisfy the workload demands for our applications, we needed to do some capacity planning. So essentially, we tried a bunch of different things where we would actually analyze over time how much traffic we were receiving at different points in the day, and then we could then what we did was we actually used scripts to scale up and scale down in order to meet that workload requirements. Because once you try to consume more request units than you've provisioned, you'll start to experience some rate limiting. Now, that's not to say that manual throughput is a bad idea at all. If you know that your workloads are stable and fairly predictable, then provisioning throughput at a manual hard level is completely fine. However, if you're like us, you were suffering, well, if you have more unpredictable workloads, then there is another approach. So Autoscale Throughput, I believe, was announced at Build 2020. I think it came GA Build 2020, but essentially what it is, what Cosmos DB does, it automatically scales your throughput based on the workload range that you define. So essentially we say, okay, Cosmos, you're going to handle the capacity planning, and we're just going to focus on our application. Now, using Autoscale, what we do is we set a maximum level of throughput that we want either our database or our container to scale to. And what Cosmos DB will do, it will scale between 10% of this maximum level and the maximum level, depending on the operations or the amount of the amount of operations being executed against our databases or collections. So billing is still done on a per hourly basis, but essentially you're only charged for the highest request units that Cosmos DB scale to within that hour. So if your application is sitting idle, there's nothing going on, essentially what's happening is that you're only being charged at 10% for the maximum throughput level that you set. Cool. Okay, so what I'm going to do now is I'm going to kick off into a couple of demos. And I'm just going to check if there are any questions. Oh, there are lots of comments. Are there any questions that I've missed out? It's got a couple of MongoDB users. Simon, you've used table and document. Fantastic. Okay. All right. I'm just going to kick off into a demo. So first off, I'm going to show you all how to actually provision a Cosmos DB account via the portal. Just going to zoom in. Okay, so I've saved it as one of my favorites, but it's fairly straightforward. You can actually search Azure Cosmos DB. I know it's right there, but you can just search it there if you don't have it. You can, if there is a reserved capacity option. So if you know you're going to be a long-term, or if you've done some dev and test with Cosmos DB and you want to reserve some capacity for long-term use, there is that option. But what I'm going to do is just click into Cosmos DB. I've created an account before, so I'm not going to make you guys like watch me provision infrastructure. I know that's boring, but essentially we can give our Cosmos DB account a name. And then we choose the API that we want to have provision on our account. So Cosmos DB is a multi-model database service, but when you create your Cosmos DB account, you choose the API that you want to configure for your account at the start of it, at the start of the life of your Cosmos DB account, and you can't change it after you've selected it. So you can't say, okay, what I'm going to do is I'm going to provision an account with a SQL API, but then over time you think, probably graph data is going to be a little bit more suited to our needs. You can't go and update your account to use the Gremlin API. You need to create a new one. It's a foundational service, so you can provision your account anywhere. I'm just going to pick Australia East. And then you've got, you can choose your capacity mode. So in the slides, I talked a lot about provision throughput, and that's provisioning throughput at a constant rate. But there's also the serverless option in preview that we can have. And essentially what that is, just in like a little nutshell, instead of having throughput provisioned at a constant rate, essentially you're only charged for the operations that are performed against your account. So I have one of my examples I'm going to show a bit later. I actually use a serverless account because I'm not expecting a lot of traffic on that application. So whenever someone performs an operation that interacts with my database, I'm only charged for that operation rather than being charged for it sitting idle or not doing anything. There's also a free tier offering that the Cosmos DB team provides. So if you're going to use this provision throughput option, you get 400 request units and 5 gigabytes of storage for free in an account. That is limited to one account per subscription, but if you're trying Cosmos DB for the first time, that's a really great offering to have. We can choose the account type. That's just the experience in the portal and the Explorer. We can enable geo redundancy, so we can actually pair our Cosmos DB account with Australia Southeast, and you can add more regions to the account later on. We can enable multi-region writes, so we can have multiple write regions for our Cosmos DB accounts, and we can also enable availability zones. You can provision your Cosmos DB account with inside a VNet if you want to. You can enable it with a private endpoint. You can make it wide open if you want to. There it is within the virtual network. Also at the start, Arafat talked a little bit about backup policies. So Cosmos DB provides two different backup policies. You can't switch between them, but essentially there's periodic, or how it used to be, and essentially Cosmos DB will automatically back up your data at certain periodic intervals, and you can choose how long you want that backup to be retained for. And you could also, by default, or before you could actually customize it, there were 2 copies of your data, and these were retained in a storage account in the same region as your write region, or one of your write regions if you're using multi-master write modes. You can actually change this to retain more copies, but there is a cost to that. And then there's also this continuous backup, which I'll talk about a little bit later. We can bring in our own customer managed keys. So if you're to do some data encryption, so you can actually bring in any keys that you manage that are sitting in Key Vaults. There, I think at time of recording, the Azure Key Vault's the only one supported for this. We can add tags if you use tags to manage your resources in Azure. And that should be everything. I've missed a couple of things, but I've already provisioned something earlier. So that's one way of doing it through the portal. For those of you who use infrastructure as code tools, my favorite is Terraform. We use Terraform quite a lot at work. I do like the look of Bicep. I haven't played a lot with Bicep, but I do like the look of it. I haven't tried it, but this is essentially Terraform allows us to provision Cosmos DB accounts, which is really, really cool. And it's fairly straightforward. You can just define your regions. You can define your consistency policies. I'll talk a little bit about Synapse Link in a bit when I go through the portal tour. We can enable that. And we can also hook up diagnostic settings to log analytics if we have that as well. We can do that all via Terraform as well. So for those of you who may know Blue Peter, here's one I created earlier. Essentially, when you provision your account, this is what gets spit out. And here we can manage a couple of things through the portal. So if we look at the Data Explorer, we can actually use this to view our data, obviously. So if you think about here's my database. I've got a container for stock. I can view items within that container, just through that portal there. I can also manage some scale and settings. I can also manage the scale programmatically as well. I can change the throughput from auto scale to manual, define the max request units, and there's some information around costs there, which is really, really handy. We can set particular settings on a container level as well. So time to live, essentially what that is, we can actually automatically expire data in seconds if we wish to. So for example, if we have a write optimized store, once we've written it to Cosmos DB, we might use something like the change feed to aggregate that data somewhere else, or we might take that payload, send it through to Event Hub or whatever, and we don't need that data anymore. We can actually tell Cosmos DB to automatically delete that data and clean it up for us if we no longer need to use it, to save off on some storage costs. And we can also define the indexing policy through there. So this is just a JSON file. At work, what we do is we control a lot of we manage our Cosmos DB accounts through CI/CD, through Azure DevOps, and essentially we can use PowerShell scripts to update our indexing policies as we need to change them. So we can edit our consistency. So, Times New Roman, that's cool. We can change this at any time. We can go up. So we can set it to strong, so meaning that our reads are guaranteed to see the most recent writes. We can define some lag time using bounded staleness. Session is kind of a default. So essentially, yeah. So we can change our consistency through here, or we can just define that in Terraform, as I showed you before. We can change our backup policies through here, set up our VNets, private endpoint connections, etc. Okay, so that's kind of like a really quick demo of the actual portal. So now what I'm going to do, I'm not going to go into you first. Let's go into some operations. So what I'm going to do, hopefully just kick this off. I'm actually going to zoom in as well. There's not a lot of real estate going on there. It's going to take a little time to start up. Okay, while that's starting up, what I can do, thinking about it, is just essentially just describe what this is. So what I've got here is I've got an API that's I'm building using Azure Functions. Just put you there. So when you're ready, you can let me know. And essentially all this is doing is really just performing some simple CRUD operations. So I've got a simple bookstore API that allows me to create books. Don't want to see diagnostic tools, I'm fine. Delete, perform some queries by getting all the books by a certain category, getting a specific book, and updating a book. That's all started, or it's starting. So what I've done here, I'm actually going to stop you. If I go into my startup class here, essentially what I've got is I've got this Cosmos DB client, and I'm just passing in through my connection string, and I'm adding that as a singleton via the startup class. But what I can do, we can actually configure our Cosmos DB client by passing in some client options. And in this, we've got a variety of different options available to us. So we can actually define the connection mode. So we can either work with direct or gateway. So direct is used to connect to the data nodes. Gateway, we can actually set up some proxies to make requests to our partitions. We can define a consistency level for read and write operations. So let's say, for example, in this for this account, I've defined it at the strong level. What I can do is I can actually set a weaker consistency level for this particular application. I can't go stronger. So if I've got an account that's set at eventual, I can't say, okay, for this particular application, I need all of my operations to have strong consistency. I can't do that. We can only go weaker. And there's a bunch of different, there's a variety of different ways that we can actually configure our Cosmos DB account at the client level. So we can specify which region our application is going to be. This application is going to be in. We can enable content response on write. I'll go into that a little bit later. We can define some HTTP client factories. We can configure some retries, so we can configure the wait time on rate limited requests. There's a variety of different ways that we can actually configure our Cosmos DB account. For now, we'll just keep it we'll just keep it as it is. I'm going to go into this book service class. Essentially, what I'm doing is I'm injecting my Cosmos DB client into this book service class that I've got. I'm performing a variety of different operations. So we'll start by adding a simple book. And essentially what I'm doing is I'm defining this items request options. So for this particular operation, I want to define some, just want to configure the way that these operations are going to perform. And essentially this property enable content response on write. Just going to F12 into this. Essentially every time we add an item, we're essentially performing an operation that's using this type of item response of generic type. And in this class, we have a variety of different properties for us. So we get some headers, we get the generic resource that we're trying to persist. And essentially, one way that we can optimize our writes is by essentially saying, okay, for this resource, once we've performed our operations, I don't want that resource returned back to me. Now, that doesn't change how many request units you use to make that operation, but it does optimize the bandwidth of your operations by not returning the item back to you if you don't need to use it. Just taking a look at this headers class. Let's see if I wanted to show anything from. Oh yeah, we have a variety of different properties that we can use. So we can actually see how much a operation costs using this request charge. We can use e-tags. So say if we have two write regions performing operations on the same item, we can use e-tag to deal with any concurrency issues. So just go back. So essentially, when we perform any operations, we're performing it against this container, which we've got by actually calling this get container method on our Cosmos client. And when we add an item, we're specifying what the partition key for this particular item is, and that's the category. And we're also passing through these request options. Here we're actually deleting a book. So when we delete this item, we're deleting the item of type book, passing through the book ID, and then also the partition key. Remember earlier, we can actually perform efficient operations if we do know the ID of the document that we're trying to perform against. So here we're just specifying this book ID, and then we've also specifying what the partition key is as well. Here we're just performing a simple point read. So again, we've got a partition key. I wonder why that's awful. I think I need to change that. And also we've got book the ID of the document, so we can actually perform a point read, point read on our item, and return the resource back to us. So essentially, this is of item resource type. We're just asking this service to get the content of the response and return that back to the user. We can also perform a wide range of queries. So here I've got a query definition. So I'm selecting all the books where books belong to a specific category that I'm providing to this method. And we can use with parameter to add parameters to the SQL query. And we can also, this gets returned back as a feed iterator. And this essentially keeps track of the continuation token when we're retrieving results from this query. And here we can specify some query request options. So I'm specifying the partition key. I can also specify the consistency level at an operation level as well. I can determine how many items I want returned back to us, or the maximum amount of items returned back to us each time we iterate through the query, and a bunch of different other properties as well. And finally, I've got an update here. With updates, here I'm actually replacing the item, but we can also upsert an item as well. So the Cosmos DB client allows us to, if the item doesn't exist, essentially it will insert the item, or if it doesn't exist, it will just upsert it. Cool, let's see this in action. I'm actually performing this against my serverless account. So I'll actually open you up. I've got my book container, or database and container all set up, ready to go. Fantastic, my functions are ready. Cool, so here's my data sitting in Cosmos DB. Just having a look at that. Cool, so what I'm gonna do, I'm actually gonna delete this first item. Oh, what's going on here? Oh no, it's just restarting. Okay, well, that's okay. I'll just get this item. And what I'm going to do is I'm actually going to perform a delete on this. So I've got Postman open. So I'm going to open this up. It's a new request. Okay, so hopefully when my function starts up, I'll have an endpoint that just says, okay, for delete operations API/book, I just pass in the category and the ID. And come on, it's finding it. Hopefully it just doesn't time out on me because I'm streaming. Oh, sweet, fantastic. Oh, well, let's try things and see if anything breaks. Okay, so I've got my endpoint ready to go for this delete operation. So /API/book with category and book ID. And what I want to do is I want to delete that book with the weird ID. So I actually go into my delete book class function, sorry, and we've got to check breakpoint against it already. All right, sweet, enough talk. Let's send it. So I'm sending the request. Hopefully Visual Studio will hit me up. Depending on time, I might jump straight into the change feed one as demo. Hadn't quite anticipated it was going to take this long, but hopefully my breakpoint gets hit soon. All right, sweet. So essentially we've invoked this function using an HTTP request. So now it's going to find the book that we want to try and delete. So just press F10 on that. Hopefully it's going to find it. And if it doesn't find the book, we'll just return this not found result. But if it does, essentially then we'll call on our book service class to delete the book from our Cosmos DB container. All right, so it's found the book, so it will skip past that. And now it's going to go and delete the book from my Cosmos DB container, from that book container that I've got there. Sweet, that looks like it succeeded. So hopefully, if we go back into Postman, we should see a 204 result come up. Sweet, so there's my 204 response back to me. If I just refresh this quickly, hopefully, yeah. So there's our item with the funny ID deleted. So that's kind of like a delete, and so there's our delete operation. Just looking at time, right? What I might do is just go off into my change feed demo. So I've got this this code repository on GitHub as well, so I'll share that link if you want to have an if you want to just explore that. But there's just some basic implementations of some CRUD operations that you can perform against your Cosmos DB account. Okay, so moving on into this function now. Essentially, what I'm demonstrating here is the use of the Azure Cosmos DB change feed. Now, essentially, this is one of my favorite features in Cosmos DB. Essentially, the change feed will listen to creates or updates within your container, and you can actually use that to essentially it will produce those changes in a sorted list in the order of when it was changed. So using Azure Functions, we can actually create functions that are invoked through the Azure Cosmos DB change feed. And essentially, these get written to this this list of documents, and we can actually perform operations of the changes that occurred within that container, and we can do something with them. So in order to initialize, in order to set up our Cosmos DB a trigger function, we provide it with the database name. So I've got a database, not on my serverless account, but in my provision throughput account called stocks. And this is going to be my write optimized store. So it's just a bunch of stock information. Come on. I love the lag time for streaming content. It's great. So we've just got some basic information, just some pseudo data about some stock information here that we're going to be dealing with. And essentially, I've set up, so I'm going to say, listen to this database name on this particular collection. I've got this connection string setting, so I've got a local .settings.json file that specifies my connection string. I have something called a lease collection name. And essentially, when we're working with the change feed, we need a lease container to manage the checkpointing for the Azure Cosmos DB change feed. So essentially, what this does is it will kind of like checkpoint what progress the change feed has made in a particular container. And with Azure Functions, you've got this really nice parameter, so you can actually create it if it doesn't exist, which I've set to true. Now, by default, Azure Functions will listen to it will invoke the change feed every 5 seconds. But we can configure this between 30 seconds is the maximum, or if we want to be really aggressive about it, I think the minimum is 0.1 or 0.5, but that's quite aggressive. But you can fine tune how often you want to poll the change feed. We can choose to start from the beginning. We can use multiple write locations if we've got multi-master writes enabled on our Cosmos DB account, and we can also put a prefix on our least collection, as I've done here. And what I'm doing is essentially any changes that are being written to this stock container, I'm essentially saying, okay, we're going to materialize this this document, and we're going to add it to another container called stock aggregate. So if I go back into my Cosmos DB account, I've just got an aggregated container, which I've indexed by, well, what stock index that particular stock lives on. So here's a property of index. Here, this one's in NASDAQ. This one's S&P 500, NZX, etc. Take a look at the stock aggregate. Yeah, and essentially I'm not doing anything too fancy within this service. All I'm just saying is just create an item and partition it by stock index. So I'll start you up, and I've got this all ready and raring to go in terms of the request, and I'll just generate, instead of 10 documents, what I'll do is I'll just generate 1,000. My endpoint is, has it even started yet? That's thinking about it. So essentially, I've got this other function here that just is going to be invoked by, invoked by an HTTP trigger. I'm just at this endpoint generate stocks, just passing through a number of stocks I want to generate. Going to just generate some fake stocks, and for each stock, each stock within this list, I'm just going to add it to that right optimized store. And once it's done, it's just going to throw 200 at me. So no pressure, computer. All right, sweet. So I've got my endpoint. I'm going to send that off. And what I'm going to do, I'm going to go back into my Cosmos DB account. Just open up my items store again. And I'll actually zoom out a little bit because we don't need to. That didn't zoom out at all. Okay. So there's a little test I did earlier of 10 documents. Just going to try and refresh that if Chrome plays nicely with me. Oh. Still thinking about it. What I'm going to do, just close it, make sure the response is not cached. Open up the items. Sometimes when I'm working with the portal, sometimes if I click refresh, nothing's happening. Okay, it might be just a little bit slow, but essentially with all these items that are being persisted here, essentially that change feed function is then just producing this the same document, but it's got a different partitioning strategy. So we're partitioning it on index. And yeah, I'll just leave that. Okay. I'll just close that for now. Sweet. That code is also on GitHub as well. So if you wanted to check that out, please feel free to do so. All right. So just some key takeaways as we look to wrap up. When you're first starting to develop applications with Cosmos DB, one of the real recommendations that I have is really think about how you're going to be querying your data and model your data accordingly. Make sure it's partitioned right. Make sure that you pick a partition key that evenly distributes to achieve optimal scale. Think about your workloads and how it's going to how it's all going to perform within your application. And do explore free and serverless throughput options when you're doing your dev and testing to formulate how much throughput you're going to need. One of the big mistakes that we did when we first started, we didn't really take time to appreciate the subtleties of throughput and how to actually manage throughput. And if you get that wrong, not only are you not going to get the performance benefits that Cosmos DB provides for your applications, but it's also going to cost you a lot of money. And that's the important factor. That's an important thing to keep in mind when you're developing applications. You don't want to spend money if you don't have to. Okay, so now before we jump into any questions, I'm just going to go through some roadmap stuff. I had a chat with Ben Griffin, someone who's works for Microsoft in Australia, was kind enough to provide this and said, hey, you can share this with the Sydney user group. So big shout out to him. If you're a Cassandra developer, I'm not too heavily involved in Cassandra, but essentially there's in preview right now, there's also an Azure managed instance for Apache Cassandra. So this provides you the ability to provision native and manage Cassandra clusters within Azure, and you can do some automated deployment and scaling operations with that. A big feature that I like is Azure Synapse Link. So in Azure Cosmos DB, it's a transactional, mainly optimized for transactional workloads, but thanks to Azure Synapse Link, we can actually enable analytical operations onto it. Currently, the API support is for both SQL and MongoDB. This is both generally available. I think Cassandra is under a gated preview that you can reach out to the team if you're running the Cassandra API of Cosmos DB and you want to use Azure Synapse Link, you can reach out to them. But essentially, what Azure Synapse Link does, there's this idea of an analytical store. So it's a column optimized store that's really optimized for those analytical queries. So you can actually run queries within Azure Synapse on your data in Cosmos DB without affecting your transactional workload performance. So it's a bit of a game changer. There's also support for MongoDB API 4.0. So for MongoDB 4.0. Before that, I believe only 3.2 and 3.6 was supported, but now there's support for 4.0. Continuous backups and point-in-time restore is in preview. So this is great for recovering from accidental writes or delete operations within a container. You can actually also restore deleted accounts, databases, and containers as well. And you can restore this to any region where your backups exist at a particular point in time, rather than relying on the two previous backups or how many other backups that you've defined to retain. You can actually do it at a more granular level using continuous backups. There's RBAC control with Azure Active Directory, so you can authenticate any data requests using Azure AD with more fine-grained and role-based permissions. And you can actually audit this using diagnostic logs to retrieve the AD identity used when accessing your data. In private preview, there's sub-petitioning. So this allows you to have 3 levels of hierarchical partition keys. So if you're using synthetic keys, or you have scenarios where your partition keys can exceed 20 gigabytes and 10,000 request units, essentially you can use sub-partitioning to solve that. And you don't have to have any sophisticated app logic to handle those synthetic keys. That is in private preview, and you can sign up for that using that link. And what I might do is I might actually start copy and pasting links into the comment section to share that with you guys. And also in private preview, when you're doing local development with Cosmos DB, you don't have to provision an account. You can use a local emulator. Traditionally, that was limited. Well, previously, that was limited to only Windows-based workloads, but there is a Linux emulator that is coming out. Currently, it's only supported within the private preview for the SQL API, but you can actually develop and test your application locally without creating an Azure subscription or incurring any costs. And this will be supplied as a Docker image, and there's a sign up for that as well. So if you want to learn more, they've got some more links for you here as well. So there's a great website, gotcosmos.com, which is a great introductory point to Azure Cosmos DB. There's great links on architectural guidance, use cases, samples, more learning resources. That's kind of like a one-stop shop for Azure Cosmos DB when you're first getting started with it. I've got links to data modeling in Cosmos DB because we didn't talk about it too much tonight, but there are differences for data modeling in Azure Cosmos DB compared to traditional relational workloads. And I've also included some documentation to throughput and partitioning. And then finally, the Cosmos DB engineering team have actually developed 2 days worth of content of deep dive hands-on labs related to Azure Cosmos DB. So if you wanted to get your hands dirty with Cosmos DB and really go deep into the product, I'd really recommend checking that out. Cool. So that wraps up my talk for tonight. Thanks for listening. If you do have any questions, we'll just crack into them now. And as we do that, I'm just going to go crazy with the links and just post them in the chat.
Yeah.
Great.
Thanks a lot, so Will. There are a couple of questions, but you can go on, post the links. Meanwhile, I'll ask the questions. So are there any disadvantages by having the item ID as the partition key? I take it that every item would then be in their own partition.
Yeah, so if you have read optimized, if you're performing read operations, since item ID is granular and unique to every document, if you're looking to optimize your containers for read workloads, that's probably not a good idea to partition by the document ID. That's probably too granular a partition key. Yeah, that's one example with the item IDs, and it's more optimized for write operations rather than read operations. If you're wanting to optimize the transactional reads that your applications are performing, think about the type of queries you're going to be performing, and then look for a filter that's quite common when you're performing those reads. But if you have an idea of what the ID is and you're looking to do some basic point reads, IDs. ID can be good for those situations, but it's something that I personally would steer away from.
All right. Yes. The other one is database level provision throughput more about cost or more about cost and performance?
Yes, primarily yes. If you don't need guaranteed performance for a container, so to actually illustrate this, we have particular examples with our applications at work where, depending on what's happening within the life cycle of our applications, we need some user interventions, and essentially those items will get persisted to that container and a user will interact on them. We have a couple of containers sitting within a database, and we don't need guaranteed performance at the container level. So from a performance perspective, we can just let the database provision throughput at the database level and just let the throughput be shared between those containers. If you do need provision throughput, but you can afford to not have that guaranteed performance at the container level, then the provisioning at the database level is the cheaper option, and it would be the smarter option in that case. All
right. So this is another vertical of the questions now. I've seen myself that people are using NoSQL for the sake of using it. So what are the best use cases of NoSQL, and when do you think that they should never use or they should not use it?
For not using that, if you're looking for that transactional performance that SQL provides, if you're working with data that has complex relationships between different entities, you're better off sticking with relational data stores.
Okay.
there's an aspect we didn't touch too much on data modeling tonight, but there are various the way that we model data for NoSQL databases is just a little bit different to what we traditionally do in SQL environments. And if we have kind of weak relationships between our data, that's when you can really opt for more for the NoSQL approach.
All right. Yes, makes sense. Makes sense. What about, somebody asked if you were using VS Code. So no, you were using Visual Studio.
There is a plugin for if you are using VS Code for Cosmos DB where you can manage your accounts. I don't think I have that set up on my VS Code. But I was using Visual Studio, obviously. I'm a .NET developer and I prefer that to using. I don't use .NET for VS Code. I'm one of those traditional guys. I actually asked a question about that. I think Simon responded to me.
Yeah, so I also like Visual Studio. So now you have given us the link of gotcosmos.com. Is it the best place to start for someone who has never worked on NoSQL or these kind of technologies, and he's or she's from the back like old school database modeling side, and he or she is coming from the traditional SQL or traditional relationship modeling side, and if they want to skill up themselves, is gotcosmos.com the best site for that?
Probably not for your foundational NoSQL knowledge. It's a great introduction to Azure Cosmos DB, and there is links to documentation that touch a little bit on the fundamentals of NoSQL. But that website's really just like an introduction for Cosmos. It's a product site that it's managed by the product team, so it's really there just to introduce Azure Cosmos DB, not NoSQL in particular.
Okay. So is there anything where they can go, or someone who would like to get their hands on about NoSQL and then move into this Cosmos DB side? Is there any way?
Not any resources that I have to hand, but I will dig some out and share. When I find some good resources. Let me think on that one.
Yeah. So cool. So now I think, let me see, there's one more comment. Oh yeah, one more question from Elena. Do you use any data modeling tool for data modeling in Cosmos DB?
Not any sophisticated tool. Basically, whiteboard approach. That's what I use. A lot of trial and error, which is probably not the best answer, but that's my answer. Yeah.
All right. Okay. I think we do not have any other questions. So time to announce the giveaway. So if you are still connected, if you want to win an Azure Pass, this is the link. It is very simple link. So what you have to do is to type on your browser, fill up the form, and we will get back to you with the Azure Pass. It is as simple as that. And if you have joined the past episode or past Meetup live, then contact me or Azure Sydney user group on Twitter, and we'll send you some other stuff than the Azure Pass as well. So these are two surprises for you. If nothing is coming up, then I think we should call it an evening now. So, and I think on the Will side, it is later than, I think it's 8:54. Is it the case? Okay.
Yeah,
so, yeah.
That's right. Yep.
All right, then. I think we should now, since we are not getting any more comments. So thanks everyone for your time. Next month we will be, hopefully we will be having another guest from outside of Australia, taking the advantage of all the virtual events. So we'll be joined by another MVP discussing about the custom vision and some of the IoT stuff as well. So the dates will be announced very soon. So keep an eye on the meetup.com, and we'll be announcing it very soon. And on this YouTube channel, you will see the placeholder for sure. That's it for tonight. I hope that you have enjoyed it, and people are saying thanks to you, Will. So thanks to you as well. Yeah, thanks, and goodbye for tonight.
Cool.